different layers of our convolutional neural network? We generally have 4 layers in our convolutional neural network. Talking about the first one, which is the input layer. As the name is suggesting itself that it will take some input in the form of images. The input layer, it represents the input to the convolutional neural network. An example of it could be a 28 pixel by 28 pixel grayscale image. Unlike the other feed-forward neural network, it do not flatten the input to a 1D vector, and the input is represented to the network in 2D only as a 28 by 28 matrix. This makes capturing the spatial relationship easier. So what is the function of the first layer, that is the input layer, is to take the input in the form of image. So this image is an example, we can say it can be a 28 by 28 pixel grayscale image. We do not flatten it into a 1D vector, rather we keep it into 2D only as a 28 by 28 matrix. So what will happen? It will make the capturing the spatial relationship between the various elements of the images easier. Second, the most important layer, that is a convolutional layer. This convolutional layer, it performs most of the working of our convolutional neural network. The convolutional layer, it is composed of multiple filters. Suppose we have a 28 pixel by 28 pixel grayscale image. Each pixel, it is represented by a number between 0 to 255, where 0 usually represents the color black and 255 represents the color white, and the values in between, they will represent different shades of gray. So what do we do in this convolution layer? We can say in convolution layer we apply different types of filters to represent our 28 by 28 pixel grayscale image. Normally if we talk about the image, we will take the unit as pixels. So each pixel, it will be represented by a number between 0 to 255, where 0 will represent the color black and 255 the color white, and the value in between, they will represent the different shades of gray. What all does happen in this layer of convolution? Convolution layer, there are basic 5 things that take place, or we can say these are the convolutional operators. These are the 5 parameters that will take place in this convolution layer. The first one is to filter. Convolution is the process of placing the 3 by 3 filter on the top left corner of the image. If we have a particular image, we place a 3 by 3 filter on the left corner of the image, multiplying the filter values by the pixel values. We will keep multiplying the filter values by the pixel values and adding the results. After doing this, we will move the filter to the right 1 pixel at a time. Like our image, it is composed of number of pixels. So what we will do, we will place a 3 by 3 filter on the top left corner of the image initially. After that, we will multiply the filter values by the pixel values and we will add the result. After this, what will happen? We will move the filter to the right 1 pixel at a time, and we will keep on repeating this process. When we get to the top right corner of the image, we simply move the filter down. That means we have started applying the filter on the left corner. After that, we will keep on moving 1 pixel at a time to the next after obtaining the result. When we come to the right corner, what do we need to do? We need to shift the filter down 1 pixel and then restart from the left. Again, we have to follow the same process. This process will end when we reach the bottom right corner. That means the whole image has been applied with filters. Second thing that we do here is padding. If we want to keep the resultant image size in the same way, we can use padding. We pad the input in every direction with zeros before applying the filter. If the padding is 1 by 1, then we can add 1 0 in every direction. If it's 2 by 2, we can add 2 zeros in every direction, and so on. That means basically padding, why is it being used? This padding basically is used for the purpose of keeping the size of image the same. We add some extra extra zeros to make padding into the image. If the padding is 1 by 1, then we can add 1 0 in every direction. If it is 2 by 2, we can add 2 zeros in every direction, and so on, it will keep on happening. Then come the next one, that is stride. This is another important component of convolutional neural network or neural network. They are tuned for the compression of images and the video data. Stride is a parameter of neural network filter which modifies the amount of movement over the image or maybe the video. For example, if a neural network stride, it is set to 1, the filter will move 1 pixel or we can say 1 unit at a time. So that is the main purpose of this stride. Stride, it is a parameter of neural network filter which modifies the amount of movement over the image. If a neural stride, we have set it to 1, that means filter will move 1 pixel or we can say 1 unit at a time. After that, the next parameter that we apply here on the convolutional layer is a dilation. When we apply, say 3 by 3 filter to an image, our filter output, it is affected by the pixels in a 3 by 3 subset of the image. If we like to have a larger receptive field, we could use dilation there. If we set the dilation to 2, instead of a contiguous 3 by 3 subset of the image, every other pixel of a 5 by 5 subset of the image, it will affect the filter output. So that is how the dilation parameter works. Next is the activation function. After the filter, it has scanned the whole image. We apply an activation function to filter the output to introduce some form of non-linearity. So we have seen that what are the basic 5 parameters that we apply on the convolutional layer. These basic 5 parameters, they are very important and the main component of our convolutional neural network. So we have talked about the input layer, the convolutional layer. Comes the next layer, that is the pooling layer. The pooling layer, it performs the downsampling to reduce the spatial dimensionality of the input. It decreases the number of parameters, which in turn reduces the learning time and the computation time, and even the likelihood of overfitting. The most popular type of pooling is max pooling. It is usually a 2 by 2 filter with a stride of 2 that returns a maximum value as it slides down the input data. In the very similar way that we have talked about the convolutional filter. So here pooling layer, it is very important. It performs the downsampling to reduce the spatial dimensionality of the input, which in turn will help reducing the learning time, the computation time of our convolutional neural network. Next is a fully connected layer. This is the last layer in the CNN. We connect all the nodes from the previous layer to this fully connected layer, which is responsible for the classification of the images. So this is the last layer, that is the fully connected layer, which will connect all the nodes from the previous layer and which is responsible further for the classification of the image. After this layer, the classification of image can be done. Talking about training for deep CNN. If we have a deep convolutional neural network, how does this training happen? Suppose we want to represent a backward slash and the forward slash. So we can represent it in the form of array or matrix, we can say. The boxes here you can see which are colored, they represent a pixel value of 1 and 0 if they are not colored. That means a pixel value colored thing will represent a pixel value 1 and the white thing will represent a pixel value 0. So if we are training a simple CNN, so how will it be trained? It will be trained in the form of these pixel values, out of which some will be colored, some will be white. So if we have different things, like for an example, very simple example I have taken, we are saving the image of backward slash and the forward slash. In case of backward slash, since we can have the value here and here, so those two symbols are colored. In this very similar way, the reverse of that is a forward slash. In that, the other two blocks are covered. So if we want the backward slash, so that means the first image will appear. If you want the forward slash, that means the second image will appear. So this is a basic thing that how we can train our deep convolutional neural network. Talking about the next one, that is very important here, the computer vision task. If we are using image recognition in the field of convolutional neural network, we are definitely applying them on the computer vision task. Convolutional neural network, it powers the image recognition and the computer vision task. Everywhere, wherever we are applying our computer vision task, this CNN will empower, because it is solving our purpose of image recognition. Talking about that computer vision, what is computer vision? It is a field of artificial intelligence which enables computers and systems to derive meaningful information from the digital images. If we want to derive some meaningful information from the images, even from the videos or other visual inputs, and based on these inputs, we can take the action. So, computer vision, it is a field of AI which enables the computers and the systems to derive meaningful information from the images, videos and visual inputs, and based on that meaningful information, it will perform the action. So the ability to provide the recommendation, it distinguishes it from the image recognition task. Some common application of computer vision today which can be seen are, first of all, this computer vision task, they can be applied in the field of marketing. Today, the social media platform, they provide suggestions on who might be in the photograph that has been posted on a profile. So, making it easier to tag various friends in photo albums. So, today, so many social media platforms, they are using this field for the marketing of their products. And the other industries also, for the purpose of marketing, they are using this computer vision task, which in turn is using our convolutional neural network for the purpose of image classification, image tagging, and many more. Healthcare. Computer vision, it has been incorporated into radiology technology. It enables the doctors to better identify the cancerous tumors in the healthy anatomy. That means in the field of healthcare also, we are applying this field of computer vision task. In almost every field, whether we talk about radiologies, the x-rays, the anomalies in the MRIs or whatever, it enables the doctors to better identify the various diseases and to categorize it into different parts. So in the field of healthcare, we are using these computer vision tasks. Then retail, visual search, it has been incorporated into some e-commerce platforms. It allows the brands to recommend items that would complement an existing wardrobe. That means if you have bought certain products from any particular website, then similar products will be displayed to you the next time also. Then automotive, today, while the age of driverless cars, it is not yet emerged, the underlying technology, it has started to make its way into automobiles. So improving the drivers and the passenger safety through features like lane line detection. Today, this field of computer vision, it is going to be applied in the field of automotive. We are surely going to have the driverless cars soon, because this is working in the field of AI, or we can say deep learning, where we have started to make cars or where we do not have any drivers, and if using the features like lane line detection, etc.